Think about this. How do we do this problem?
Because it's multiplying, the radicals are allowed to combine, so it'd be root 18.
Yes, they can talk to each other because you're multiplying. Just like x plus x times y, that'll give you xy. But x plus y you can't do. It's just x plus y. Okay, so that's root 18, but then we're not done. But let's do this our fast, non-tree way.
Okay.
So we break up root 18 to what? Oh, and the number you want to think of, in order for this to work, is you want to think of numbers like, you want perfect squares. Like 4, 9, 36, 100, 81, 49, 64. You want these numbers in here.
Okay.
Otherwise, do the tree.
Okay. So we'd think of 9 and 2, so it'd be 2 root 3.
Yeah, that's right. So you did 9 times 2, and then in your head you're like, well, that's the same thing as the square root of 9 times the square root of 2, and then we know the square root of 9 is 3, so it's 3 root 2. Cool. All right, so then you have 3 root 2. Wait, we're just done. It's just 3 root 2. Right? Okay. How do we do that?
Because the square root's on the outside, you're multiplying root 3 by root 3.
Correct.
So that would just be 3.
Right. Why do you say that?
Because root 3 times root 3 is 3.
Good. Because you're right, and that's exactly how I do it. I say, the square root of, doesn't matter whatever's in there. If you're taking it to the power, it's just whatever was in the root, right? Mm-hmm. And that's because the square root of 3 squared is the same exact thing as the square root of 9, because it's root 3 times root 3, which is root 9, and root 9 is 3.
But if it was on the inside, what would we do? If it was root.
Yeah. So if it was, are you saying that if it
didn't have the parentheses?
It's the same thing.
Okay.
Yeah, and that's super confusing, but it's the same thing. All right, so what are we going to do here?
We're going to multiply the 2 together and then...
Nah, well, you could, but that's just making things worse.
Okay, so simplify and then combine them?
And I don't know a factor of 240. That's just too much work. I don't I know 15 times 15 is 225, and that's about it. So I'm just going to I would just factor tree this guy.
Mm-hmm. Okay.
All right, so...
85.
Great. So 245, 5, and then without a calculator, let's just do our fast math. So since we know it goes into it perfectly, do you remember how to do our fast math? I think I showed you this. So all right, can 5 go into 2?
Yeah.
Can 5 go into 24?
Yeah.
How many times?
4 times.
What's the remainder?
1.
Is it?
No, just kidding. It's 4.
4, yeah, 4. All right. And can 5 go into 45?
Yeah.
How many times?
9 times.
9. So I would do it like this, as long as you know the number goes into it perfectly.
Yeah.
So it works with 2s very well, works with 10s and 5s, because 5 goes into anything that ends in a 5 or a 0, 10 goes into anything that ends in a 0, and 2 goes into anything that's even.
Okay.
All right, so we have. I would have never thought of this, but we have this. So what do you want to do now?
Now we have 2 7s.
All right, 2 7s. Okay.
And we can take our 7s out, and we have to keep our 5 in the inside.
Mm-hmm. So we have a 7 root 5, right?
Yeah.
Times root 3, and that gives us...
That's where I don't know.
Okay, so here we have the buddy to the 7, because it's always buddies times buddies.
Okay.
All right? So you have the buddies that are out of jail, and you have the buddies that are inside of jail.
Mm-hmm.
So out of jail, you have a 7. Out of jail, you have an invisible 1. All right, so buddies times buddies.
So 15 root 15.
Okay.
And then just 7.
Yeah. So, and inside remains inside, outside remains outside, but you may create something inside that you have to now take out. Right? Like if we had done, like, let's see, like 7 root 5 times root 25, right? So what would that become?
I don't know what 20 times.
5 times 5 is 125.
Okay, so it'd be 7 root 125.
7 root for 125, but now you got to take 125 over here. Long bubble extension. 125, and then always just put your primes on the left just to make it easier.
Yeah.
So what do you want to put off to the side
5
here?
5 and 25.
Yeah, 5 and 25.
Then 5 and 5.
5 and 5.
And we can take out a 5 and keep a 5.
Mm-hmm. So 5 root 5, right?
Yeah.
So this is 7 times, and this is 5 root 5, and here is that business. Or I'll do it like this, I guess. That's that 5. That's that 5. 5 root 5.
So 35 root 5.
Mm-hmm.
Dang.
That's as complicated as it gets.
Okay.
Okay, so this answer is 7 root. All right, so buddies times buddies.
So 105 times 7.
Okay, let's punch that out.
Here, you do. That's 735.
All right, 735. 735. And we're inside the root, right?
Mm-hmm.
Because everybody's in the root. And it's just invisible 1 times invisible 1, which is invisible 1.
Mm-hmm.
Okay. All right, so 735. And what about g's?
We have g squared and g squared, so it's g to the 4th.
And why is it g to the 4th?
Because you're adding them.
Good. G to the 4th. And anything else?
And then we have our f. No, we just have one f.
So what do I write?
F to the 3rd.
F to the 3rd.
Just keep it.
Then we got to factor treat this guy. We got to do more than just that. We also have to deal with anything that we can chop these guys down. So let me tell you what we have. We kind of have this. We have root 735, and I'll just kind of write these other guys off to the side right here. Times g times g times g times g times f times f times f. That's what we have.
Okay.
Okay, so let's factor tree 735. So how many times so what's 735 divided by 5?
147.
147. Let's add these up and see if 3 can go into it. So
11, 12.
12. So that means that 3 can go into 147. All right, let's take out a 3.
49.
Okay, and then we have our 7 and 7. All right, so circle your buddies. Cross one out. 1 comes out. 7. Root what?
Root 15.
15. Okay, so now we have 7 root 15 times g times g times g times g times f times f times f. So I'll show you like the long way of doing this, and then we'll do a faster way.
Okay.
All right, so the long way is say, all right, well, I got a buddy here. Cross, 1 comes out. All right, these are my buddies. Cross, 1 comes out. And buddy here, cross, 1 comes out. And then you end up with 7. And then what's g times g?
G squared.
G squared. And then you have your f. Then you have your root. And the loners, which is 15f, stay inside the root.
Okay.
Okay. That's kind of like I don't know, not the most direct way of doing it, but it works. Okay, so let's go back to what we should have had was 7 root 15. And then we have g to the 4th and f cubed. You with me?
Yeah, I think I know what you're going to do.
Yeah.
Isn't it like you subtract it from the root?
You divide it by the root.
Okay.
So, because that's what you're doing here. So there's an invisible 2 right here. So you're seeing like how many doubles do I have?
Yeah.
Right? And if there's a 3 there, then you'd be saying how many triples do I have?
Yeah.
So you just divide it. So there's a 2 right there. So I'm going to just put that 7 back down. All right, so you take this 4 and you say, like, all right, 4 divided by 2 is what?
2.
2. Any remainders?
Yes. 2 remainders.
No.
Oh, wait.
Because it goes in even. It's like
Yeah.
it's like this kind of thing, right? Just bam.
Mm-hmm.
Okay, so it's g to the 2 with no remainders.
Mm-hmm.
If there were a remainder, then the remainder would be in the root.
Yeah.
Okay, so let's do f. So 3. So 3 divided by 2 is 3 divided by 2. Like how many times can 3 go into 2?
0.
Well, sorry, I did that totally wrong, by the way. How many times can 2 go into 3?
Once.
So because it's you're basically you're putting this number underneath that right there.
Mm-hmm.
Okay, it goes in once. Remainder what?
Remainder 2. No, 1.
1. You understand?
Mm-hmm.
Okay, so then you have this number here is the g to the power of what? That's it's the g to the power of what's coming out of the root. So this number here, so sorry, that's, well, it's f, not g, but f, and then this number is this number. Do you follow? Like,
Yeah.
that 1 is that 1.
Yeah.
Okay, inside the root, we have our 15 from before. This guy's completely gone because it came out, but this is the one with the remainder. So that remainder 1, that's right here, is
what stays
here
inside.
with the f.
Okay.
And that's that.
So then we would also have. Oh no, our G's are good.
Yeah, that's it.
Okay.
So we would write it without the invisible powers of 1. So it'd be 7g squared f root 15f. That's all you can do.
Perfect.
Okay, so what do we do?
We multiply the 21 and the 3 first,
Mhm.
which is.
And if you can take something out of the 21, it'd be great, but you can't. Okay, and then I'm going to show you like a different skill you can do. So you can go, all right, we have the square root of 3 times 7, which is our 21, right?
Mm-hmm.
Times 3 times h to the power of what?
H to the power of 4.
H to the power of 4. Then I'm going to go ahead and I'm going to go and write this as 3 times 3 times 7 times h to the power of 4. Do you know what we can do now?
Can we combine our 3s?
You could, or you can say like, all right, well, I got my,
doubles.
I can
so
do
you
that,
take
I
it
can do
out.
that, I can do that. Or at the very least, I can do root 9 times 7 h to the 4th, and you can take your root 9 right out,
Mm-hmm.
which is 3. Do you see that?
Yeah.
So that's why I didn't combine them, because I saw that. I was like, wait, we're going to make a bigger number, then we're going to factor tree it, and we're going to end up with these as our factors.
Mm-hmm. So it's 3 root 7.
So it's 3 root 7 h to the 4th, and we have an invisible little 2 right there.
Mm-hmm.
Okay, so now what do we do?
So this is when you do like 4 divided by 2.
Yes. So
So then it's just 2, so you can take it out.
yes. So we have h to the 4th over 2, and then that becomes h to the 2 with no remainders.
Mm-hmm.
So that just becomes h to the 2 right out. If we had a remainder, then it'd be h to whatever that remainder is inside the root.
Okay.
So we have 3h squared to the square root of 7. We good?
Mm-hmm.
But if you notice right here, I was trying to trick you. You fell right into my trap, and you didn't notice that there's a g there. And that was, did that on purpose. So there's a g that goes right there, which goes right there, which goes right there, which just kind of goes along for the ride. And there it is right there. And there's our real answer. All right, what do we do?
We are going to multiply our numbers, but
Yes.
let's think, can we simplify? We can't because 35. Well, the first thing I thought of is like 7 and 5, and you can't simplify.
Correct. It doesn't have a 3 built into it. Yeah, so we're going to do whatever 35 times 3 is.
105.
All right, so we have 105. And now we have w to the power of what?
Power of 9.
All right, so w to the power of 9. And we have a little invisible 2 right there. And so what do we do with the 105?
We are going to see if we can, factor it and then see if we have any pairs.
Yep, so we'll factor tree 105. What are we going to put over here?
5.
5. And I'll race you. Ready? Set, go.
21.
21. Okay. So then we have
3 and 7.
3 and 7. All right, so,
Those numbers all suck.
Yep, they're horrible. This is a family show, by the way. I'm not sure about that S word. All right, so we my kids say that word. All right. All right, so just 105, right?
Or do you want to? Oh yeah.
We can't do anything with it. All right, so then now what?
So then we just now we work with our W's. So we do 9 divided by 2.
Correct.
Which is 4 with a remainder of 1.
So that means we have w to the what right here?
4.
4, and then w to the what right here?
1.
Good. All right, so then we have w to the 4th, and then square root. You don't need the 2 over there, and you have 105 w. Now